Anil Kumar, sharing with you 4 important questions from test point of view. These are related to trigonometric Pythagorean identities, and we will see how, from given conditions, we can derive relations. You can always join my classes by sending an email on the address given above. Enjoy the journey of success. And now, the class with Arya. Hi, Arya. How are you doing?
Hi, Anil sir. How are you? I'm good.
Very good, very good. So, how is your practice on trigonometry going on?
So far so good. I've been trying to do at least like 5 questions per day, but considering I do have other courses along that, it's kind of hard, but I'm trying to get through as much as I can.
Okay, so I selected 4 questions for you today, in which we'll give you a trigonometric equation, and from that equation, we'll find another condition. So, do you see these 4 questions on the screen?
Yes.
Can you please read them?
If cosecant theta plus cotangent theta equals x, find the value of cosecant theta minus cotangent theta.
Correct. Second,
If cos theta plus sine theta equals to root 2 cos theta, show that cos theta minus sine theta equals root 2 sine theta.
correct. Third,
If secant theta equals to x plus 1 over 4x, prove that secant theta plus tan theta equals 2x or 1 over 2x.
and the fourth question.
If a cos theta minus b sine theta equals c, prove that a sine theta plus b cos theta equals plus or minus square root of a squared plus b squared minus c squared.
Yes. So in these questions, one thing is common. We are given one condition. For example, the first one, cosecant theta plus cotangent theta is x. That is given to us. We need to
Right.
figure out what is cosecant theta minus cotangent theta. Likewise, in the other questions also, we are given some conditions, and we need to figure out the similar kind of an expression. Correct?
Okay.
Now, to solve these kinds of questions, you can easily use Pythagorean trigonometric identities and solve them, right?
Yeah, I was thinking like if you know what cosecant theta plus cotangent theta is, then you could bring the x. Well, it's not theta and x are different, right?
Yeah, yeah.
So
X is the value for
right,
cosecant theta plus cotangent theta.
right.
So, how do you think we can solve this particular question?
Well, they want us to find the value of cosecant theta minus cotangent theta, and that basically I believe equals to 1.
No. You remember the Pythagorean theorem? Uh,
Yeah, I do, but I
1
don't
plus
remember
cot square
cosecant
theta, right?
theta.
1 plus
Yeah,
cot square theta is cosecant square theta.
cosecant squared theta. Oh, so do I just bring the 1 plus cot
Yeah,
squared
yeah,
theta
yeah.
into that?
So you could rearrange this and write this as cosecant square theta minus cot square theta, correct?
Right. But
And then
what
this,
I'm confused about is that we only have cosecant theta and cotangent theta. So is this difference of squares?
yeah, difference of squares, you're right. So it is cosecant theta plus cot theta times cosecant theta minus cot theta, right?
Right.
And we have to find minus, then we can isolate that. So cosecant theta minus cot theta will be what? 1 divided by cosecant theta plus
With
cot theta,
cot theta.
which
Right.
is given to us as 1 over x, as x,
Right.
right? So substitute x here. So we get this answer. You get the idea, right?
Okay, so we don't have to use like the value of an expression that is given. You can manipulate the expression to
Yes,
then. Okay, I got confused because I thought you had to use just the single theorem, and then I got confused. We're like, how would we derive the square into it?
right. So we could do like this, right? So we given this expression, so we use this value here and found the required value likewise, right? But
Right.
yes, what you were saying exactly, we could use in different questions. Right? We could use different strategies. Here is another very interesting one. Cos x plus sin x is square root 2 cos x. And we need to find what is cos x minus sin x.
Okay, so we know that cos squared x minus sine squared x equals to 2 A
Yeah.
cos 2 theta or
Right.
cos 2x.
Right. So you are saying we know that cos square x plus sine square x is 1, right?
Right, but we could,
In this
since
case, we are given cos x plus sine x
right,
equals to square root of 2 cos x. We are given this. We can square it, right?
right.
So if we square both
Oh,
sides, then what do we get?
then we get cos squared x plus 2 cos x sine x plus sine squared x equals to 2 cos x.
Now see, we want cos x minus sine x, right? So what we could do is 2 cos square x, we can take all these terms there. Let's rearrange. So we get 2 cos x sine x.
And we also know that cos squared x plus sine squared x equals 1. So then
Yeah.
that's all that's left.
Correct. So the right hand side now becomes cos square x minus sine square x. Do you see that?
Right.
Because 2 cos square x minus cos square x is cos square x. And this can be written as sum and difference product, right?
That's right. So cos x plus sine x and then cos x minus sine x.
And this is equal to 2 sine x cos x, right?
Right.
So we can now find what we need to find, which is cos x minus sine. So what is cos x minus sine x equals to?
2 sine x cos x over cos x plus sine x.
Correct. And the denominator is given to us as
Root 2
cos x.
cos x.
We can simplify by dividing, right? So what do
Oh,
we?
so this is 2 sine over root 2. But then you can rationalize, right?
Yes. Do you see
I
that?
see. Yeah, I see. So you have to like use your Pythagorean identity and then prove.
Correct. So that is
So
what we do, right?
yeah, I might have to do these questions again when you post this video, just so I
Yes.
can get like a hang of it. Cause yeah,
Very
and
interesting
I
questions.
haven't seen something like this now.
Yeah. Another very beautiful question. It's very difficult. So secant theta is given to us as x plus 1 over 4x. We need to find what is secant theta plus tan theta. It could be
Right.
2x or 1 over 2x. How do we do this, right?
Oh,
So we know secant theta is equal to x plus 1 over 4x. Now, what is the relation between secant and tan? We know that, yes.
secant is 1 over cosine, and tan is sine over cos.
I thought
But
it,
secant squared theta minus tan squared theta equals 1.
correct. So tan square, 1 plus tan square theta is secant square theta. So we could, from here, write down what? We can write down that tan square theta equals to secant square theta minus 1. Is it okay? So we know what secant square theta is, which is x plus 1 over 4x whole square. Now, right, minus 1, correct? We substituted the value given to us, x plus 1 over 4x, correct?
Oh, I see. Yeah.
Now let's expand this. We get x square plus.
Well, then you expand and just simplify from here.
Yeah. So 2 times ab will give us half, right?
Right.
And then plus 1 over 16x squared minus 1, right?
Right.
So we get here tan square theta equals to x squared. And then we have plus 1 over 16 x squared. And half minus 1 is minus half, right?
Right.
Can you write this as a perfect square? X.
Well, yeah, you can if you can just use your quadratic formula if it's even.
X minus 1 over 4x whole square. You see that?
Yeah, you can also do that.
Correct? So
Right.
this is tan square theta, right?
Right.
So what is tan theta equals to? So tan theta will be plus or minus square root of this, right?
Right.
Which is basically plus or minus x minus 1 over 4x. Is it okay?
Right.
Now you can find what is secant x plus tan x. This is what we want to figure out.
Right, because you just add the x minus 1 over 4x plus or minus plus secant value, which is x plus 1 over 4x, and then you solve from there.
So that will give you either 2x or 1 over 2x.
Right. Give you two solutions. That makes sense.
Very important question and difficult too. But you understand the solution? Great. Last question. A cos x minus b sin x equals to c. A sin x plus b cos x is what? That is what we want to do now. So how can we do this one? So look here. We are given a cos x minus b sin x equals to c. Do you see this right hand side? It's kind of a square plus b square minus c square square root.
It looks like the Pythagorean identity for like the right angle triangle. That's what I was going to say. So
if we square both sides, we might get the result. Do you see that?
Yeah.
It indicates. Let's square and continue. So a squared
cos x.
I'll write 2ab. Better write 2ab.
Yeah. 2 cos. Oh yeah, you can do it. 2ab cos x sin x minus b squared sin squared x equals c squared.
But you see, we want with a, we want sine. But with a, we have cosine. So what can we do now?
Oh, 1 minus sine squared x.
Perfect. You see?
Yeah.
I mean, the question suggests us that you should do this, right? And we are able to then get the solution.
Right, because you want b being cosine and you want a being sine, so you have to do it like this.
Yes. We want a square plus b square minus c square, so we'll take all of the terms to the other side, and we'll leave here a square, and we have b square. We'll bring c square here and take other terms. We get a square sine square x. We have plus 2 ab cos x sin x. And we have plus b square cos square x. Correct?
Correct.
Now, right hand side is what? Is it a perfect square?
Right hand side, you said to take the square root of those values, right?
Yeah. B cos x.
Because here you can just write this as a plus b the whole square. Can you not?
And then we get our result. Does it make sense?
Yeah, that makes a lot of sense. Yeah.
So that is how we could do these questions. Perfect. You understand?
Understood.
So we solve these questions in 14 minutes. You know that? 12 minutes.
Oh wow.
Even less. Okay. So let me stop sharing this, and I'd like you to summarize. What did you learn?
So we went through these proving identity questions, but you have to manipulate the expression to then prove it in a way that you can utilize your Pythagorean identities. Like in the one that we just did, you could see that it's like a right angle triangle question. But when you manipulate it, you can use your Pythagorean identity for sine squared theta, cos squared theta plus sine squared theta equals 1. And so basically it's just manipulating and proving your identities to then supplement the answer of the expression that you're given.
Perfect. So, but the tricks which you learn are very interesting and useful. You can always try these tricks in solving or simplifying equations and finding solutions to some difficult questions. So that could be a base for a very difficult question. Okay. So with that, we'll end our class on this. I hope you understand and appreciate it. So we'll continue from here in the next class. Okay.
Sounds good.